All right, whoops, that's not the right screen. How was that, a computer? All right, well, let's dive in. So the plan for today is to finish 12.2. We probably won't finish 12.3, but I'll do a lot of 12.3, not finish probably, yeah. So 12.2 will be due on Thursday. So we're going to get through 12.2, and then we'll get a lot through 12.3, but not finish it. So I'll put it down here. 12.3 and 12.5 will be due next Tuesday. So we'll start 12.3 but not finish is the plan. We'll see how it goes. Yeah, and we're almost at the end here of new stuff. What I mean is we have 12.2, 12.3, and 12.5, and then after that, the rest of the course, the last 3 weeks, is all trigonometry, which you've had before, right? So it's going to be a review. We're going to start from ground level. So most people can relax in the trig section. Most people do well at the trig because you've had it before. So you're about at the end of the new stuff. We're close. 12.3, 12.2, 12.3, 12.5, and it's it. No more new stuff. I'll do trig, though. I will do 4 or 5 sections to remind you of trig and prep you for calculus, which we'll use trigonometry a bit. All right. So on that note, let's move forward. We have an exam after Thanksgiving, right? Not before. This is Thanksgiving's next week, yeah. So obviously we don't have an exam before Thanksgiving. We have an exam the week after Thanksgiving. When we come back from Thanksgiving, we have a practice exam Tuesday, and then then that Thursday exam number 4. 1 exam to go, and the final. All right, arithmetic sequence. What is it? These are basically functions where you only plug in the numbers 1, 2, 3, 4, etc. So you see what they're giving me there, that n plus 14 thing? That n plus 14, you don't need to do anything with the brackets around it or anything, whatever. Just n plus, it's kind of like a function. It's like if somebody says, f of n is n plus 14. You don't really need to write that. It's like a function, and you can plug things into it, but you're only going to plug in whole numbers. That's what a sequence is. So in other words, I'm going to plug in 1. I'm going to plug in 2. I'm going to plug in 3, etc. And see what we get. Plug in 1 to the formula. What do you get? 1 plus 14, 15. That's the first number in the list. Plug in 2. 2 plus 14, 16. It's the second number in the list. Plug in 3. 3 plus 14, 17, etc. So you don't plug anything in between the whole numbers, right? You only plug in 1, 2, 3, 4. Basically, you're saying 15 is the first number, and 16 is the second number, and 17 is the third number, etc. Does that make sense? That's why you're only plugging in 1, 2, 3, because you're finding the first, the second, the third. That's what a sequence is. It's just a list of numbers. It's just simply a list of numbers, and they almost always have a pattern. So what's what's the pattern? What's happening every time? What's the jump from number to number in this list? Just going up by 1 every time, huh? Just add 1, add 1. That's the simplest pattern we can have. Starts at 15, adds 1 every time. Very simple sequence. So the common difference, that's 1. That's their way of, what's the difference from term to term? I always call it the jump, but whatever you want to call it, difference or jump, they call it difference. The jump, the difference from term to term is just 1 for this sequence, for this formula, which generates that sequence. All right. Yeah, they just want me to find the difference and then list the first 3 terms. That's what they are. So, all right, so we'll take the formula 6n plus 3. So new formula this time. You know what we're going to do. We're going to plug in n equals 1, n equals 2, n equals 3. Let's see what we get. 6 times 1 plus 3 is 9. 6 times 2 plus 3, 12 plus 3, 15. 6 times 3 plus 3, 18, 19, 21, etc. So the numbers are 9, 15, 21, etc. This is the first number, the second number, the third number, and on we go. Good there. Just plug in 1, 2, 3, etc. What's the What's the jump? What's the difference from term to term? 6, huh? Yeah, it's just the difference, just adding 6 every time, isn't it? That's the D, the difference from term to term, or I call it the jump from term to term. So what is the common difference? It is 6. Do you see now how we can figure out the common difference right from the formula without even seeing the numbers? We could just grab it. It's always just going to be the number next to n, huh? That's going to be the difference from term to term. Like in the last one, let me go back. The last one, what was the number in front of n on the last one? Nothing, which was 1, and sure enough, that was the difference, huh? So whatever number's in front of n, that'll be the difference from term to term, the jump amount from number to number. Good enough? Easy enough so far? Mm-hmm. It's like we're in a whole new world here, right? So when we entered matrices, that was a new kind of thing. We found out the rules for how you deal with matrices, how you add them, subtract them, multiply them, divide them. Now we're in this new world called sequences. We're learning how they work. So let's take a look here. All right. So 6 minus 8n. So n equals 1, n equals 2, n equals 3. So go ahead and plug in to that formula, 1, 2, and 3. Find the first 3 terms. And then find the common difference from term to term. Give you a second. All right, so we plug in 1. What's that, negative 2? 6 minus 8, negative 2? Bless you. Plug in 2. Was that minus 10? Plug in 3. That's that 6 minus 24, minus 18. And on you go. So negative 2, negative 10, negative 18, etc. First number's negative 2. Second number's negative 10. Third number's negative 18, etc., etc. What's the difference from term to term? Going down 8, sure enough, it's always the number in front of n. The difference, the jump amount, negative 8, and there's the first 3 numbers in the list. Or they want the first 4, don't they? I didn't notice. So the fourth number would be something else. Minus 26? Yeah. There we go. We good? Easy enough? All right. Okay, so we've got the formula. 1/3 minus a half n. So there's my formula. Going to plug in 1. So I'm going to plug in 1 there. So when I plug, let me do this one with you. We get fractions here. So plug in 1, we get 1/3 minus a half times 1. So that's 1/3 minus a half. Now how do we subtract 1/3 minus a half? Common denoms, huh? So we got to multiply top and bottom to get common denominator here. So top and bottom of this one by 2, top and bottom of this one by 3. So we get 2 6 minus 3 6 minus 1 6. So the first term in the list is minus 1 6. So that's n equals 1. Now let's go to n equals 2. So 1/3 minus a half times 2. Like that. Which is 1/3 minus. And what do you do with a half times 2? Put 2 over 1 right? Whenever a whole number interacts with a fraction, put it over 1. Cross cancel. So it's 1/3 minus 1. Good so far? And then you know what we need to do. Common denominator, huh? So make this 1 become 1 over 1. And multiply top and bottom by 3. And so we get 1/3 minus 3/3. So minus 2/3. Everybody good so far? Like that, keep going. So n equals 3. It's going to be 1/3 minus a half times 3, which is 1/3 minus. Now, again, what do? We all comfortable with that? What do you do when you got a half times the 3 here? What happens? Yeah, because the 3 is over 1, right? Whenever a whole number's interacting with a fraction, it's over 1, so it goes to the top. So 1 times 3 over 2 times 1 is 3/2, huh? Good. And then, common denominator time. Multiply top and bottom of this one by 2. Top and bottom of this one by 3. It's 2/6 minus 9/6 is minus 7/6. Good there? First 3 terms. They want 4 terms. I'll let you find the 4th. I'm tired of this problem now. What's the difference from term to term? What's the jump amount from term to term?
It's negative 1/2.
Remember, you can always just look right next to n. Right? Just look right next to n. The difference, the jump amount from term to term is minus a half, huh? I mean, you could figure it out. You could subtract 2 of these, but what you're going to find is whatever number's next to n. It's going to be minus a half, remember? We good with that? So I'll move on if you've got that. See.
What's the difference?
All right, so the formula is natural log of 8 to the n. Plug in 1, 8 to the 1. So, and they want to build the calculator, huh? All right, here, I'm going to go grab mine. So, natural log of 8, that's 3 decimal places, 2.079. And then we do n equals 2. Natural log of that is going to be 4.159 if you round to 3 places. N equals 3 would be what? Natural log of 8 to the 3rd. Whoops. What am I doing? There we go. I'm getting 6.238. And then they want n equals 4. Natural log of 8 to the 4th. I'm getting 8.318. Y'all getting those? Not good. There's the first 4 terms. And what's the difference? What's the jump amount from term to term? Well, it's not as easy to tell. We can't just do the little formula trick this time. So we're just going to have to subtract 2 of the terms. Right? Whatever the jump amount, the difference is whatever the difference is from term to term. So just take 4.159 and subtract 2.079. The difference will come out to be 2.079. Right? Questions on that one? That okay? Yeah. Oh, inside. Yeah, right. Yeah, the parentheses, go like that. Is that good on there?
Just showing in the questions up that you can move the n over in front of the LNA.
You can. They're using log properties. I don't find any real need to do that. So there we go. All right, I'll move on. More thorough answer to the parentheses question. That was a good question. Yeah, how you know that the parentheses, yeah, it's natural log of 8. Yeah, the 8 to the n is understood to be the plug-in to the natural log. That's why that power is in the parentheses. It's all the plug-in to the natural log. All right, so let's keep going right here. So number 6. Now they're going to change gears a little bit. They're going to give me the first, A1 means first term, so let's learn this language. So we're in this new world again, sequences, and we got to learn how they talk in this new world here. A1 is pretty simple. A1 just means first term. So when they say A1 equals 6, they're saying the first term is 6. Like if you were to list them out, which I'll do now, the first term is 6. And the D, you know what D is, means difference from term to term, or jump amount from term to term. So that means it's going to go up by 2. So the next number is 8. And then it's going to go up by 2 again. So the next one's 10. And up by 2 again, so the next one's 12, and etc. Make sense how I found that sequence there? So A1's the first term, and D's the difference, the jump amount from term to term. Now, here's what they want, though. They want me to find a formula. And then, the question's off the screen. I can't, let me go. They want the formula, they want, they're saying, let me write up here, find a formula and 41st term. Okay, so there's the sequence, 6, 8, 10, 12, etc. But they want me to find a formula and the 41st term. Now, I could find the 41st term, couldn't I? Mm-hmm. It might take me a while, but I could get there, couldn't I? Because this is the first term, second term, third term, fourth term, etc. All the way down here would be the 41st term. I could find the 41st term. It would just take me a while. I could just add 2, add 2, add 2, add 2, add 2, add 2, and not lose track of where I'm at. I'd get all the way to the 41st term. But we'd rather just jump there, huh? And to do that, we need a formula. You know what this is like? This is like the difference between the olden days when you listen to cassette tapes. Have any of you listened to things on a cassette tape? Yeah. Remember that? Now there's CDs and DVDs, right? So back in the day when you had a cassette tape and your favorite song was at the end, you'd have to fast forward through all the other songs to get there. That's like that'd be like trying to get to the 41st term by add 2, add 2, add 2, add 2. But instead, now with CDs and DVDs, you just jump wherever you want, much nicer. That's what we want to be able to do here. I want to be able to jump like a CD to the 41st term. For that, we need the formula. Okay, so what's the formula to jump to any term n? So in other words, we want to say, what's the nth term? We have the first term, second term, third term, fourth term. What's the nth term?
6 plus 2n.
What is it?
6 plus 2n.
6 plus 2n. What do you think about that? Is that right? Some say no? Don't think so? Why not?
No, that's not working either.
You testing it out? Yeah, test it. Good idea. Good idea. Yeah, whenever you think something, yeah, test it out. Good job. So if you put, if it was really 6 plus 2n, then when you put 1 in for n, first term you get 6 plus 2, you get 8,
Yeah.
which is actually the second term. See the deal? And if you did the next one, 6 plus 2n, and you put in 2, 6 plus 2, 6 plus 4 is 10, you get the, so we're like behind by 1 term. It's working, but it's just back. It's close. It's just back by 1 term, isn't it?
2n plus 4?
2n plus 4? Or 4 plus 2n?
6, 2n minus 1.
Yeah, you guys are right. It's either way. You guys are both, do you mean this?
Yeah.
Yeah, and that's both this and this are the same if you multiply them out. Because that would be 2n minus 2, 6 minus 2, 4. Those are the same two formula, and they're both correct. That's right. Let me show you how and why that's the case. That is, those are both correct. It's because, let me do a frog and some lily pads here. What if we have a frog? Because I know what you guys are thinking. You're thinking, well, we got to start at 6 and add 2 n times, right? That's almost right, but you add 2 n minus 1 times. That's the only mistake with that formula. That's really close. Why n minus 1 times? Well, think about the frog with the lily pad. Here's the frog. I can't draw, so I just put an F for frog. So if I tried to draw a frog, it wouldn't look like a frog. All right, so the frog is going to jump and jump. To get to lily pad 3, how many jumps since he started at lily pad 1? 2 jumps. In other words, there's 1 less jump than where you end up. See the n minus 1 idea? To get to the 3rd spot takes 2 jumps because you already started at the first one. Make sense? So if we're already starting at 6 on the first term, to get to the 2nd term is only 1 jump. To get to the 3rd term is only 2. See how the number of jumps is always 1 less than where you end up? To get to the 4th term is only 3 jumps. So to get to the nth term is n minus 1 jumps of 2, starting at 6. Do you see the idea? You start at 6, and you take n minus 1 jumps, each of length 2. That's the right formula, which, if you simplify it, is 4 plus 2n. So, having said all that, we're not going to think that hard every time, but that is the idea. Let me just give you a canned formula that we will use every time, and in fact, I'll put at the top of the next exam. It is a sub n is a1 plus n minus 1 d. I'll give you that. You don't even have to write it on your 3x5 card. I'll put that right at the top of the next exam, along with about 4 other formulas. 4, something like that. Anyway, I'll let you know as we go. So there it is. There's the formula, which is basically becomes this. Let me show you. So we'll just use this every time. This has the idea of start at the first term and take n minus 1 jumps of length d, right? D is the difference from term to term, the jump amount. That's what it's saying. So what's the first term? 6, a1, plus n minus 1. What's the d, the difference from term to term? 2. Distribute. 6 plus 2n minus 2. And there it is. 6 minus 2 is 4 plus 2n. So you're both right. And there it is. 4 plus 2n. Oh, and now we can find the 41st term. Now we can do the CD thing. We can jump right to the 41st term, can't we? We can say, okay, now that we have that formula, and that's the first thing they're going to ask you for. That's what they want right here, the a sub n. That's a sub n because that's the nth term, right? That'll give you any term, the nth term. Now we can find the 41st term. How do we find the 41st term? You just plug in 41 for n and see what you get. And that'll be 4 plus 82. So 86. There it is. 41st term is 86. We just jump right there. Is that good on all that? Does that make sense? So you always use this a sub n is a1 plus n minus 1d. I'll give you that at the top of the next exam. We'll use it a bunch the next 3 or 4 problems. All right. So a1, the first term is 5. The difference from term to term is minus 6. Can you find the formula first off? So they want the formula, so go ahead and use an is a1 plus n minus 1d. It's what we always use. So use that formula, plug in a1 and d, simplify it a little bit. Give you a second. All right, so plug in a1 is 5 plus n minus 1d. D is negative. Since we're multiplying the d, right? It's times the d. So times negative 6, so multiply that. We get 5 minus 6n plus 6, which is 11 minus 6n. There's the formula, good on that. Now they want me to find, what is it, the 65th term. So 65th term. Hey, 65th, with that like TH on the end, that's called an ordinal, and I'm not really into names as much as to help you. In a minute, they're going to start moving the formulas all around. It gets a little confusing. But if you remember this, it'll really help. Anytime they give an ordinal, a number that implies ordering, do you understand the difference there? That's always in. That's always in all the formulas. If you just know that, it really helps. So ordinal numbers are those that imply an ordering. So it's the difference between me saying 65, that's not an ordinal, and 65th, that's ordinal now. That implies ordering when you say 65th, right? So all the ordinals, those are always ordinals. Ordinals are always in. Whoops, there's no S on my always. They're always in. The ordinals are always in. So just know that in all of our formula work. So I take the 11 minus 6 in, go, oh, 65th. That's the order number. That's the n. Plug that in. That's some big ugly number. Somebody got that? Nobody got that? Yep. 379. Good. So that's the 65th term. Those terms are going down, 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 aren't they? Is that okay? Questions on that? Okay, so the 29th term, find the 29th, so they want me to find the 29th, and they're saying the first term is 7, the difference is 1/4. So the first term is 7, first is 7, the difference, the jump amount from term is 1/4. You know what I would do? I'd make that a decimal, 0.25, you know? I think it'd be easier to work with decimals in your calculator. So go ahead, so find the formula. They're not asking me for the formula, but I think it'll help you. Find the formula, and then when you got it, plug in 29 for in, right? Because that's the ordinal, 29th, right? Ordinal. Plug that in for in, see if you can get the 29th term once you get the formula. So there's the formula. An is A1 plus n minus 1d. All right, first term, the A1 is 7. And the difference is 0.25. I'm just going to use a decimal. So what do we get? 7 plus 0.25n minus 0.25. So 7 minus 0.25, what is that? 6.75 plus 0.25n. There's the formula, and now we just plug into that formula the ordinal. This is n. N is 29. Plug it in. Get 6.75 plus 0.25 times 29. Trying to find the 29th term. And I'm getting 14. 29th term is 14. Are we good there? Questions I can answer? You guys are awfully quiet. I hope that's a happy quiet. Let me know if it's not. We can back up. All right. So A1 is root 15. D is root 15. They're both the same. So they're giving me that. They want the formula. And then when you get done with that, they want the, 31st. So they want the 31st term. There's your n. There's your ordinal. N's 31. But first they want the a sub n formula. So they want the formula, then the 31st term. Can you do that? A1 is root 15. D is root 15. So a sub n is a1 plus n minus 1d. a1 is root 15. D is root 15. All right, and we want to find, oh yeah, and I better clean that up first, huh? So that's root 15 plus root 15n minus root 15. No, these cancel, don't they? So it's just root 15n. There's the formula. Just root 15n. Okay? And now, take that formula, root 15n, and plug in 31. So it's root 15 times 31. You can leave it that way. You can put the 31 in the front if it makes you feel better. Either way is fine. Both are good. Nothing more you can do with that. Is that good? Questions on that one? All right. Okay. So they're giving me the terms. They go 4 13/3, 14/3, 5 ... And they want me to find the 55th term. All right, let me give you a minute. See if you can find the 55th term. So I would encourage you to start with the formula. AN is A1. This is always a good place to start. Whenever I'm reading a problem, I don't have any idea, I write down the formula first off. So there's my formula. AN equals A1 plus n minus 1d. There's my formula. So I got to use that thing somehow. So I know A1. A1's 4, huh? First term's 4. The trick is the D. See if you can find the difference. So if you're not sure, you just have to subtract any two terms, right? Because it's the same jump amount, same difference from term to term to term to term, always the same. So just take any two terms and subtract them. Any two consecutive terms, I should say. Any two terms in a row and subtract them. And you'll get the D, the difference. So what's the D? 1/3, right? It's going up by 1/3 every time. You can see it easy if you look in the middle two. If I just say, well, look, 14/3 minus 13/3, that's 1/3. It clearly went up by 1/3 there, didn't it? But is that what happened from like 4 to 13/3? Did it go up by 1/3? Yeah. What's 4? It's 4 over 1. Multiply top and bottom by 3. It's 12/3. That's what 4 is. That's another way to write 4. And if you add 1/3 to that, what do you get? 13/3. See? It's true, isn't it? And if you take 14/3 and you add a third, you get 15/3, which is 5. Yep. It just looks weird, but it is going up by a third every time, isn't it? So the D is 1/3. So the A1, what's A1? A1 is 4. Now, you don't have to do all that I just did. I'm not saying you have to do all that. Really, all you have to do is subtract any two terms. I hope I didn't confuse you. Just subtract those middle two. 1/3. Boom. You got it. You don't need to check them all. Just any two, subtract them. D's a third. So that's the common difference, a third. So then here's our formula. And now, actually, you know what? They're not even asking me for the formula, so I don't have to simplify it. I can just grab my 55 and plug it in right now. It'll be a little easier. Don't even bother to simplify it. They're not asking me for it. They just want the 55th. That's our ordinal, 55th, right? So that's always in. Plug that in. Times a third, which is 54 times a third. Good. And isn't that 18? 4 plus 18, 22. There it is. The 55th term is the number 22. We good? Questions? All right, so we're about halfway through this section. We're getting used to things. Now they're going to make it a little more involved. So what they're going to do now is they're going to start playing Name That Tune, except it's Name That Formula. They're going to give us just a little bit of information, just enough for us to come up with a formula. So they're going to say the eighth, we're thinking of some formula. The 8th term is 4, and the 21st term is 30. Name that tune. Name that formula. So, how do we do it? How do we take just that little bit of information? The 8th term is 4. Go down the line. The 8th one is 4. The 21st one is 30. Just from that, can we find the formula? Well, the way I'm going to suggest it, what do I always do when I look at a problem and I have no idea? I write down the formula. AN is A1 plus N minus 1D. That'll be right at the top of your next exam. So just write that formula down. It's a good place to start. Okay, now what can I do? How can I use, let's just take the first bit of information. 8th term is 4. How can I plug 8th term is 4 into that formula? Where does the 8 go first off? What is the 8? Yeah, he's an ordinal, so he's in. Y'all with me? So here's where I'm talking about, where things start getting confusing for students. In the past, I've noticed this is where they get confused. What to plug in for what. That's why I gave you the ordinals are in. Ordinals are in. Ordinals are the TH kind of thing. So 8th, that's in. So that means everywhere you see n, he's now 8. So A sub n is A sub 8. A sub 1. N is 8. D. Good to there so far? I just plugged in 8 for n. Because 8th, that's my ordinal, that's n. Now, what is this right here? A sub 8. That means the 8th term, doesn't it? And what is the 8th term? It is, so I can just replace that with 4. A sub 8 is 4. They're telling me it is. And 8 minus 1, that's 7. So I get to there. Good to there? See what I did? I just plugged in the 8 for n, A sub 8, and then realized, well, A sub 8 is 4. They're telling me 8th term is 4. And then I worked out the other side, 8 minus 1 is 7. Okay. Now, that's a formula that has 2 unknowns, A1 and D. Now, do the same thing with the second batch of information. 21st term is 30. So right over here, A sub n is A1 plus n minus 1d. Plug in the 20, this is n is 21. Again, so A sub 21 is A1 plus 21 minus 1d. And what's A sub 21? What is the 21st term? It's 30. So put in the 30, and this is 20d. Are we good to there? Now I've got, notice, 2 formulas with 2 letters. That's like 2 formulas with x and y. I can solve that. Got 2 formulas with x and y, except it's A1 and D. Same kind of thing, right? So just take the other one, put it right down here. Or, yeah, either way, it doesn't matter. Just put them, stack them vertically, one on top of the other. Now, you could solve 2 equations, 2 unknowns, however you want. I think, though, there's a by far easiest way here. The easiest way is to just run a negative sign through the bottom one. Multiply through by -1 on the bottom one. Add them up because the A1s will cancel. That'll work every time we're doing these. See what I did there? Remember, when you have 2 letters, 2 equations, you want one of the letters to drop out, don't you? You need one of the letters to drop out. That way you can solve. So 4 minus 30 is minus 26. The A1s have dropped out. And 7d minus 20d is minus 13d. Am I going too quick? Does everybody see what I'm doing there? How we doing? So from the top again, I just, 8th term is 4, so I plug in 8 for n, and then said the 8th term is 4. So I got that equation, did the same thing for the other. Have the two equations with A1 and D. Multiply the bottom one or the top one, it doesn't matter, by -1. Add them up. That way you get one of the letters to drop out. We don't want two letters. It's too hard to solve with two. Get down to 1. Now we can solve for D. Divide by -13. D is 2. So now we've got D. Once you've got one letter, you know you just plug in to get the other one, huh? Plug in really anywhere you want. It's impossible to go wrong. So I'll just, whatever, just grab like this one right here. Bring it over. 4 equals A1 plus 7D. So plug in the D is 2. Plus 14, subtract 14, and -10 is A1. So I got A1. Okay, that a little sloppy there. Can you read all that? Just solve for A1. So A1's -10. So now I've got the formula. What do I mean I got the formula? Well, the formula is, again, it's AN is A1 plus N minus 1. Well, actually, they don't even ask me for the whole formula. They just say, hey, what's the first term? Well, that's A1, -10. Then they say, what's the difference? Well, that's the D, 2. And then they ask for kind of, are we good so far? And then they ask for kind of a funny thing. What's the recursive formula? Well, recursive, remember, just means what do you each term, what do you do? Recur. You go back to the last term. So they're saying, again, basically, long story short, they're just saying, hey, what's the first term? Well, they're same thing it was a minute ago. They're just asking the same question again. And then they say, and any term is the previous term plus what? Well, the difference. So you just answer A1 and D twice, basically. Does everybody see that? Is that second part confusing? Remember the recursive stuff we talked about last week? Any term, that means the nth term, which is like any term, is the previous term. Remember, n minus 1 means one back, previous term. So in this sequence, any term is the previous term, add 2, right? Because that's the difference from term. You add 2 each time. So in other words, you just answer A1D, A1D, you're done. Oh, they do want the formula here, don't they? My mistake. Okay, so they do want the formula. They want me to write it all out, so I better do that. So I got the D. Let me go to a fresh screen. Got the D, got the A1. Or maybe I can just squeeze it in up here. So got the D, got the A1. Put it in right here. I can squish it in there. All right. So AN is A1, N minus 1D, thing we use all the time. Now we know what A1 is. A1 is -10. And D is 2, distribute. So the formula is -10 plus 2N minus 2. -10 minus 2 is -12 plus 2. And there we go. That's what goes in that box. -12 plus 2N. There's the formula. Good? A lot of work on that one. So you want to try one of those? It's all about the two equations with two letters. Then you can answer everything. No questions? All is well? Can I move along? Got it copied down enough? All right. All right, so they're telling me 5th term is -11, 14th term is 70. So you know what to do, right? Write the A sub n thing twice. So you're going to write A sub n is A1 plus N minus 1D. You plug in for the first bit of information. 5th term is -11. Plug that information in. And then use it again. Get your two equations. They both have A1 and D. plug in it. So the ordinals are in, so fifth, that's in. 5 is in. And a sub 5, the fifth term, is minus 11. Everybody get that first equation? Minus 11 equals a1 plus 4d. So now see if you can get the second equation and put them together. So then 14th term is 70. Is 14. We get to there. Good, then put those together. Multiply one of them by -1, right? -1 all the way through, and add them up. The A1s will cancel. You can solve for D. And then I'll multiply through by -1. Add them up. What is it? Minus 90? Yeah. Then last step, divide by -9. So D is +9. So D is +9. And now just plug that in anywhere you want for A1. Doesn't really matter. Maybe I'll just grab this one right here. $90 to the 117. A1 is -47. Did y'all get that? So we got A1, we got D. We pretty much can answer any question they want now. Last thing, we should find the formula. So they're gonna ask us for everything else. Let's find the formula. So over here, I will find the formula. So the formula is AN is A1 plus N minus 1D. So A1, which is -47, plus N minus 1 times D, which is 9. The 9 distributes. So -47 plus 9N minus 9. -47 minus 9, -57, -56. There we go. Is that good there? Does that make sense? Questions on that? It's all good? All right. Okay, close it down. I'll keep moving. Got that one. All right.
Number 15, it asks for the recursive formula, but it didn't fit it.
Oh, is it? Okay, thank you. All right, so yeah, so basically it's the same question. You would do all the same work, except that, but you're right. They're asking for a different kind of recursive formula than they did before. Well, at least they didn't fill in the part I needed last time. So now as you do all the same work, you'd say, okay, 10th term is 0, so we're going to use a sub n is a1 plus n minus 1d, and then you'd plug in, you know, da-da-da, all that works the same, and I found a1 is 18, d is negative 2. How about I just jump to there? So I kind of did it in my head, and I found those out, so there they are. So then, what's the recursive formula? So a recursive formula always is of this format. an is an minus 1 plus d. That's any term is previous term, not term, add the difference. Does that make sense what I'm saying there? That's a recursive formula. Any term is the previous term, right? It recurs. It has to do with what happened last time. It has to do with the previous term. As opposed to the nth term formula, which formula, as opposed to the nth term formula, which is an is 20 minus 2n. Notice no a sub n minus 1. See the difference in those two types of formulas? Does everybody see that? A recursive formula has the previous term in it. An nth term formula just has n. In other words, the nth term formula is the CD, the DVD. You can jump anywhere. Right? I could say to the nth term formula, tell me, what's the 100th term? I could find it out right now. 20 minus 2 times 100. Right? Just plug in 100. But I couldn't do that with recursive. What's the 100th term? I don't know. Plug in 100 here. We'll plug in 100. Okay, what will it tell you? Not what you want. It'll say the 100th term is the 100 minus 1, 99th term plus d. Well, I don't know the 99th term. Right. You're in trouble. See, the recursive formula only takes you one step at a time. Do you see that? It always tells you, want any term? It's the previous term. Add the difference. Yeah, but I don't know the previous term. Well, you better find that out. Right? So recursive is only one step at a time. Everybody see that difference? Good. All right, so number 17. Let's look at sum. So notice what we're doing different now. I know how math can just kind of come at you and it's just a big mess and it's hard to tell one thing from the other. So let me help you. Do you see what's different now between this list of numbers and all the other ones we've done today so far? What's the difference between this list of numbers and all the other problems? There's plus signs between them, not commas. We're adding them, not just listing them. Does everybody see that? See the difference? So this is, in fact, this is actually called a series when you add them. And if you just list them, that's called a sequence. If that helps. I'm not going to quiz you on the names, but if it helps you realize those are different animals, right? Those are different kinds of things. So you can list them with commas, or you can add them up with plus signs, and you want to know what they add up to be. A bunch of them anyway add up to be. That's called a series. Sequences and series is this chapter. So you go into calculus, you do more fancy things, especially in Calc 2. You do some fancy things with sequences and series in higher math as well. So, all right. So this is just getting you warmed up to the topic. So we're talking about the sum now, adding them all up. You guys know the famous story about probably the greatest mathematician ever? Who was the greatest mathematician ever? Does anybody know? I mean, it's debated. There's not one considered, but there's probably three. People would probably say among three. Anyway, my opinion, I'm not an expert in history of math, but Carl Friedrich Gauss was probably, everybody thinks he's one of the greatest anyway. Carl Gauss. Anyway, he was in Germany, 1700s, 1800s? 1800s, I think 1800s. In Germany, He was a small boy, like I don't know what they said, he was 4 years old, something like that. He was correcting adding mistakes in his dad's bricklaying book, the business book where he kept the records of customers. He was already at 4 years old correcting adding mistakes. He soon did great things. He did this famous thing in third grade or fourth grade. So third grade or fourth grade, so the story goes. It's pretty well attested. It's pretty reliable story. Gauss was third grader, fourth grader, something like that. And the teacher was mad at the class or just wanted some time, I think, right? And said, all right, kiddos, I want you to add up the numbers 1 to 100 on your slates. Remember, they had slates back then, right? 1800s in Germany. They had these small little chalkboard things, right? No paper, little slate. So you imagine using a little slate to add up the numbers 1 to 100. This teacher's buying time, right? 1 plus 2, that's 3. Okay, now add 3. Okay, that's 6. Okay, erase the chalkboard. 6. Now add 4. Okay, we're at 10. Okay, now add 5. Okay, 15. All right, erase the chalkboard. We're at 15. Where are we at? 5. Okay, now 6. 21. Okay, now add 7. 28. Okay, erase the chalkboard. 28. And where are we at? Okay, now add 8. And just keep going and going and going. All the way to 100. That's what the teacher asked the class to do. Add up all the numbers 1 to 100 on their little slates. Carl Friedrich Gauss thought, well, and I'm sure the teacher thought this would buy him or her lots of time without the kids bugging him. And Carl Friedrich Gauss thought, well, let's just try something. Anybody seen this? Anybody know what Carl did? Little Carl? You guys never seen this?
I've heard the stories, I don't remember.
The details? Yeah. He thought, well, let me just reverse the numbers. He just tried something. Remember Einstein's famous quote that said, to a scientist, imagination is more important than knowledge. Meaning, you try stuff. You just say, hey, maybe it's this. You just try stuff. That is a lot of discoveries. They just tried. Carl Friedrich said, what if I just reverse the list? Write it backwards and then add them up. Maybe something will happen. All right, well, what if you add them up? Straight up and down, vertically. Straight up and down. 1 plus 100. Well, okay, 101. 99 plus 2. 101. 98 plus 3. 101. Keep going. 98 plus 3. 101. Okay, yeah, whatever. That's neat. That's cute. Yeah, it's all 101. So what? Oh, no. We're done now. We got it. That's more than so what. Do you see it? We can do it like that now. We can do the whole problem like that. Do you see it? How can I do it like that? How many 101s are there? There's 100 of them, right? There's 1 in the 1 spot, 1 in the 2, right? 1 here, 1 here, 1 here, 1 in the 98 spot, 1 in the 99th, 1 in the 100. There's 100 of them, aren't there? So how do you add 100 101s? Well, you multiply. That's how you add 100 101s. That's super convenient. They all came out the same number? Now, careful. That's going to be twice as much as we need, isn't it? Because that's the list forward and backwards, right? The teacher just wanted it one time. We did the list forward and backward and added them all up. So that's twice as much as we need, so divide it by 2, right? To get the real answer. Okay, how do you take 100 times any number? Adds 2 zeros to the back. Take the 101, add 2 zeros to the back, right? Divide by 2. Now, how do you divide by 2? Well, this is 10,100. What's half of 10,000? 5,000. What's half of 100? 50. 50. The numbers 1 to 100 must have to be 50. He took it up to the teacher, so the story goes, like in just 2 minutes or something, went up to the teacher, had the answer 50-50, and the teacher said, what? You must have cheated or something? Set him in the back of the room for discipline or something. I don't know if all that part of the story is true, but that's how the story goes. Carl Friedrich went on from there to do many other great things. He went on to, his dad wanted him to take over the bricklaying business in the little village there. The little villagers got together some money, and they sent him off to the university because they recognized his genius. And so he went to the university. He would quickly be ahead of his professors. Like he'd be taking this pre-calc class, and he'd be saying, Mr. Heron, have you thought about this and this and this? And he'd be like leagues ahead of me, and just making observations and things wildly ahead. He got his degree, but soon they just made him a professor there, and the rest is history. He went on to be an amazing man. He discovered things so fast. Like people would discover things. His publishing motto was few but ripe, meaning he didn't have time to publish everything he discovered. He discovered things so fast in math and science when he was working that he'd have his colleagues would come to him and say, oh, I discovered this one thing, Carl Frederick. And Frederick go, oh, yeah. He'd look in his diary and go, yeah, I found that out a couple months ago. That's a pretty good result. You go ahead and publish it. I didn't have time. He just discovered the big ones. When I took Physics 4A, which is the calc-based physics at junior college, it's the hardest, 4A, 4B, 4C, the hardest courses I took at junior college. You do calculus first, then you take the calc-based physics. Carl Frederick in the electromagnetism one, we had 4 formulas that were key to the whole class. 2 of them were his babies. He had 2 out of 4. So anyway, an amazing mind of prolific math science work. All right, so we can use that kind of thinking to add up that 1 to 100 is a list of numbers that are an arithmetic sequence. It's numbers that are adding 1 every time, adding 1 every time, adding 1 every time. So let's use that same kind of thinking. Here, let me put the problem down fresh again. Oh, wait, I probably had the wrong one here. Yeah, no, I got that. Oh, it gave me a pencil low, and then
You have to charge the pencil.
I do. It's really easy. All right, so there we go. So there's the question. Let's go back to the question. So, all right, thanks for that moment of history. Remember, I'm a wannabe history teacher, so I try to weave that in every now and then. I think history is very interesting. Anyway, on we go. So how do we do this? How are we going to add up these numbers? Well, you can do Carl Frederick's trick and write them backwards if you want, but I think you would prefer for me to just give you a formula. Yeah, so I'll just give you a formula. S sub n is n over 2 a1 plus an. I'll give you that right at the top of the next exam. That's another form. Don't even have to write any 3x5 card. I'll give you that one. S sub n stands for the sum. Hey, can I tell you why it's right? I don't like math to be magic. I like you to see that it's logic. If we did Carl Frederick's trick on this one, and we wrote the numbers backwards, 73, and let me see, it's going up by 2 every time, huh? So 71, 69, all the way down to 7, and we added them, we'd get 80, and, Notice what, if we did the same trick Carl Frederick did, notice what you're doing. This is the what? First term, right? And this one is actually the last term, so it's a sub n. Nth term, last term, right? So in other words, what are you doing right here? What is this? a1 plus an. And then what is this? Same thing. What is this? Same thing. They're all a1 plus an. How many of them are there? There's n of them. N a1 plus an's, and then divide by 2 because that's the list twice. See where that formula comes from? It's the same formula Carl Frederick used, right? So there's the formula. That's how they derive math science formulas like that, by using logic. Okay, let me put it back the way it was. I just want you to see that you don't have to do any of that stuff. All you got to use is the formula, but I want you to see where the formula comes from, because to me, that's much more interesting than just cranking out formulas. All right, let's crank out the formula now, though. So here we go. All right, n. What's n? I don't know. Let me hold off on n. What's a1? 7, huh? That means a1 means first term, doesn't it? Now, what's an? Last term. So let me be real clear with you. This is, if you know what the things are, I think it'll really help you. a1 always means first term. An always means last term, because it's the nth term, the last term. And what's the last term? 73. Good so far? S stands for sum. By the way, we're adding these, right? S stands for sum. The other formula we used was a sub n, which just stands for the arithmetic sequence term number. Wasn't the sum, in other words. S stands for sum, adding them up. Okay, now what's n? Now we got to have n to finish this thing. We're going to have to work the other formula to find it. This is going to be a little hard because we're going to have to use both formulas, because n is not obvious. And what does n mean? Number of terms, right? I don't know the number of terms. They start at 7, they go to 73, they're going up by 2 every time. I don't know. I don't know how many terms. I need to know how many terms. So to find n, are you guys tracking with me? To find n, use a sub n, use the other formula. So this problem will actually require us to use both formulas. The new S sub n formula, we're stuck right now. We'll come back once we get we'll use the other formula to find n, then we'll bring it back and we'll finish up with the S sub n formula. So here we go. A sub n, what's A sub n mean again? Right here. See it? last term, huh? Last term, which is 73. What's A1? First term. So last term is first term, which is 7, plus n minus 1. What's the d? What's the difference from term to term here? 2. See how I can solve that formula for n now? N's the only letter there. And then once you got that, bring it back and plug it in. 2n minus 2. What's that? 5 plus 2n. We good to there? Was that 68 is 2n divided by 2. N is 34. So there must be 34 terms up there. Feel good? Now take that thing and go right on back here and say, okay, now we can wrap this thing up. It's 34 over 2 times, what is that, 80? Just something. 121. Is it 1360? Nobody knows? Yes, 1360. And we're done. All those numbers add up to be 1360. So you see how we did it? So whenever we have adding up, we use the S sub n formula, plug in everything we know, A1 first term, AN last term, but we didn't know n, so we went over and used the A sub n formula, put in first term, last term, and the D, solve for n, 34, brought it back, put it in, finished up the S sub n formula. Got to use both formulas. Questions I can answer? Okay, so 6 plus 13 plus 20 plus dot, dot, dot plus 111. I'll write it up here to make sure you got it. Because I'm going to plug in my pencil. Turn off the screen there. So, all right, so do that one. Okay, so the S sub n formula, n over 2, A1 plus AN, like that. We know A1 is first, AN is last. The first term is 6, the last term is 111. We don't know n, so to get n, we go over and use the A sub n. AN is A1 plus n minus 1d. Again, both these formulas on the top of the next exam. This means, last, not first, last. This means last. This means first. The last term 111. First term 6. N minus 1. What's the D? What's the difference from term to term? What's the jump? Going up by 7 every time, huh? Up by 7 every time. So 7, distribute. 111 is 6 plus 7n minus 7. 111. 6 minus 7, negative 1. Add 1 to both. 112 is 7n divided by 7. So I don't know. What is that? 112 divided by 7? 16. Okay, n is 16. Bring that back. Boom. 16 over 2. This is 117. And I'm getting 936. All those numbers have to be 936. Good on that, questions? All right. All right, so we've seen this before, haven't we? In this class. Right, what does that big symbol mean? Haven't we? Yeah. What does that big symbol mean? Sum. That's a big Greek S, isn't it? Sigma is technically what it's called. It's a big capital sigma. The lowercase sigma looks like that. I don't know. You don't care. Anyway, it's a big Greek S. So it means sum. So when you see that, you think, oh, they're adding something up. Right. They're adding something up. They're saying, take this formula and plug in n equals 1, plug in 2, plug in 3, go all the way to 60, right? You start at the number on the bottom, you end at the number on the top, huh? So you start at 1, go to 60, and you're plugging into the formula 3n plus 6 every time. And then you're what? S, summing them all up, adding them all up. So that's what it says. So plug in a 1. 3 times 1 minus 6, what's that, negative 3? Plug in a 2. 6 minus 6, 0. Plug in a 3. 3. And you're adding these up. Dot, dot, dot. Last one, plug in a 60. 180 minus 6. 174. Like that. So there's the sequence they're talking about, huh? That's what they want. That's what this symbolism is symbolizing. All right, so how are we going to do it? Well, they're added up, so we're going to use the S sub n formula, which is n over 2 times a1 plus an. This time it'll be easier, though. Do we know n? How many terms? Remember, n means how many terms. How many terms? 60, right? It starts at 1. It ends at 60. You go from 1 to 60, you got 60 terms. So that's nice. We don't have to use the other formula, the a sub n, to find n. We can tell what n is. N must be 60. Everybody with me on that? See how we know that? Right? Because that symbolism said start by plugging in 1 and go all the way to 60. Start at 1, go all the way to 60. There must be 60 total terms. N is the number of terms. Yeah, let me write that to be real clear. Number A1 is the first term, AN is the last term, right? So N is number of terms. Number of terms. All right, first term, negative 3. Last term, 174. So 30 times 171, whatever that is. 5130. There we go. Questions on that? By the way, the practice exam number 4 is already up and available for you if you want to start looking at that in advance. All right. I will move on if you're good with that. All right, so try that one. It's clearly a sum. It's got the sigma notation, the sum notation. We guess. So really all we need is the first term and the last term, huh? And the number of terms. So I would just go, look, I'm just going to find the first term. And I'm going to find the last term, which is 90. That's all you need. Oh, no, you need the difference. No, you don't even need the difference. No, just find the first term and the last term. Because the formula for S sub n is n over 2, a1 plus an, huh? All we need is the first and the last. And the number of terms, which we know that's 90, huh? So, yeah, just find the first and the. You don't need to find first, second, third like I did last time. You don't need all that. Just first term, last term. That's all you need. So first term, 7 minus 1/3. So what do you do with 7 minus 1/3? Put the 7 over 1, common denominator, right? Third minus 1/3, 20/3. At the first term, 20 over 3. You good there? Then find the last term, which is much easier. No fractions. Good there? Okay, everybody good to there? Then plug in. No, number of terms is 90. First term is 20/3. Last term is negative 23. Good to there so far? So what are we going to do? Common denominator. No, don't even mess with common denominator. Never mind. Don't do that. Just take that 45 and multiply. It'll take care of the denominator for you. Yeah, don't even mess with it. I just type it into your calculator. Honestly, I would just type that in directly to your calculator. It'll just handle it. It's no problem. It'll just do it. And I'm getting negative 735. You getting it?
Yeah.
There it is. Yeah. And yeah, just type it in your calculator. A lot of you guys' calculators will do these fractions for you automatically too. Is that good? Questions on that one? All right. Okay, so find the sum of the first 120 terms of that sequence. 17, 19, 21, 23, ... Okay, so when they say find the sum, what's the first thing you should do? Write down the sum formula. S sub n, it'll be at the top of your next exam. N over 2, A1 plus A n. Remember, this means number of terms, first term, last term, right? Okay. So take it from there so you can find the sum of those. Okay, so number of terms. What's the number of terms? 120, right? Oops. What's the first term? 17, right? Okay. Now, the $1,000,000 question. What's the last term? What goes there? What's the last term? That's the only hard part here, huh? What's the last term?
245.
How'd you find it?
Oh, I just took 119, so like excluding the first term, multiplied it by 2 because that's what's going up by each time.
Yeah.
And add that to the first.
Good job, good job. That's great. If you can do it that way, it's great. I'm just going to say, look, A sub n, I need to know A sub n. I got an A sub n formula. Going to have to use the other formula, which is an A sub n formula, isn't it? You want A sub n, use the A sub n formula, which will be right at the top of the next exam. But yeah, if you have a way you can kind of feel your way through, that's great. That's probably even better. A1 is 17, first term. Oh, and n is always the number of terms. I know the number of terms is 120. And the d, the difference from term to term, it's going up by 2 every time, isn't it? So an is 17 plus 119 times 2. An is that. 255. 255. Everybody good there? Does that make sense? Is that what you got? 255. All right. So this will be 60 times whatever. Just use your calculator now. Hit the buttons. 16,320. Michael, did you? Well, I didn't listen close to what you said. What did you say again about how you did this?
I'm not quite sure that would actually work, and I'm trying to figure out like at what.
I can correct it for you. Just say it one more time. What did you say you did?
I took the 119 excluding the first term since it goes up by 2.
Right.
and I multiplied that for 238, and I added
Wait, you multiply 119.
Yeah, 119 times 2.
Good.
So you get 238.
Right.
And then I added that back to the first term.
Yeah, that should work. Yeah, 238 and you added 17. Yeah, that should work. 238 add 17, it's 225.
Oh, yeah, that.
Yeah, you're good.
Yeah.
Your method's perfect. Good. That makes sense? All good there on that one? So basically on this one, you need a sub n, you go use the a sub n formula. So always these tricky ones at the end, which I don't have time for. All right, find x so that x plus 2 is the first term. 5x plus 3 is the next term. 4x plus 1, ... That's weird, huh? That's a weird question. Find x so that that's an arithmetic, consecutive terms of an arithmetic sequence. What in the world? How do we do this? Anybody have any ideas? If you think about an arithmetic sequence, let me give you one. 2, add 6 every time, let's say. 8, 14, whatever. The difference between these two, 6, is the same as the difference between these two. That's what it means to be an arithmetic sequence. It's going up by the same amount every time. So that means if I subtract these two, if I find out the difference there, it's got to be the same thing as the difference here. This difference has to equal that difference. Does that make sense? The two differences have to be equal. Michael, do you want to say something?
I just put that formula down the way I was thinking, and I realized it's just the a sub n formula, and I just phrased it differently.
Yeah, it is. It's, no, but that's good. You're thinking the a sub n formula right. All right, so I'm going to subtract the first two. Right? That's the difference between the first two. That's got to equal the difference between the third and second. Do you see that? See how that's got to be true? Everybody see that? The second term minus the first term has got to be equal to the third term minus the second term, doesn't it? Common difference makes it be so. Right? If the jump amount is the same every time, then the jump between the first and the second, what I get when I subtract second minus first, has got to be equal to the jump between the third and the second, what I get if I subtract the third and the second, right? So distribute this. What do we got? 5x plus 3 minus x minus 2. 5x minus x is 4x. 3 minus 2 is 1. Has got to equal 4x plus 1 minus, distribute the minus 5x minus 3. 4x minus 5x is minus x. 1 minus 3 is minus 2. That equation's got to be true. Solve for x. Add x to both sides. Gonzo. Running out of room completely. Come up here. What do we got? 5x plus 1 is negative 2. Subtract 1. 5x is minus 3 divided by 5. There's what x has to be to make that true. X has got to be minus 3/5. Common difference. Is that good? The difference between the second and first has got to equal the difference between the third and second. Common difference to be an arithmetic sequence. All right, I got to move on. That'll be on YouTube. They're asking all these tricky ones. I'm going to need to say office hours here in a second for these harder ones. How many terms must be added in arithmetic sequence? First term is 10. Common difference is 5, so it's going up by 5 every time. And you want them to all, I don't even know what the last one is. You want them to all add up to be 4725. That's the sum. They add up to be that. Find n, number of terms. Remember, n is always the number of terms. How many terms, adding 5 every time, 10, 15, 20, 25, 30, 35, 40, 45, 50, add them all up, stop somewhere, I don't know where, and they add up to be 4725. How many terms? That's the question. How many terms? Well, what formula are we going to use? Are we adding them or listing them? Are there commas or plus signs. That's how you know which formula to use, A sub n or S sub n, right? The A sub n is for the commas. The S sub n is for the plus signs. S means sum. Add them up, right? So we're adding them, so I'm clearly going to use, I mean, I know we use two formulas sometimes, but there's always the main one, the main attraction, the main one we're using. In this case, it's S sub n, because it's a sum. N over 2, A1 plus AN. There's the main one. And they're telling me the sum is 4725. They're giving me the sum, actually. In number of terms, that's what they're asking me for. First term, last term. Do I know the first term? Sure do. It's 10. Do I know the last term? No, I got a big question mark there. But I've got a formula for A sub n. What's the formula for A sub n? A1 plus n minus 1d. Right? A1 is 10. N I still don't know. And the D, the difference from term to term is 5. So clean that up. Boom, boom. 5n minus 5. AN is 15 plus 5n. Take that, put it right in there. See that? Because that's what AN is. 15 plus 5n. See all that I did there?
Isn't it 5?
Oh, it is. Why did I do that? You're totally right. Going too fast here. This is 5, right? 10 minus 5, thank you. So this should be 5 plus 5n. There we go. Thank you. Good to there? Now we got to solve that equation for n. I don't have time to go slow. So I'm gonna get rid of that 2, that denominator right away. So I'm gonna multiply both sides by 2. Bye bye. 4725 times 2 is 9450. This other side is n. 10 and 5 is 15 plus 5n. Distribute. 9450 is 15n plus 5n squared. Look at that. I got to solve for n there. How do I solve that for n? Am I totally losing you? This is a harder problem. Sorry, I got to move fast. So I'm going to go to a fresh screen. This will be on YouTube. 9450 is 15n plus 5n squared. 9450 plus 5n plus 15n squared. No, 15n plus 5n squared. I get that reverse. All right. So there we go. So yeah, now what could you do? Yeah, I would divide through by 5. I don't even need a factor. Just divide. They're all divisible by 5. I'll make it a little simpler. 1890 is 3n plus n squared. Good. How do you solve an n squared equation? Get a 0, right? Whenever we have n squared, so you need to bump this over. So get a 0. We have n squared. I'm going to put them in order. Minus, right? That becomes, when it jumps to the other side, becomes a minus 1890. I would do the quadratic formula at this point. Negative b. Remember, that's what you do when you have x squared equation. Negative b plus or minus the square root of b squared minus 4ac all over 2a. A is 1, b is 3, c is 1890. I don't got time. Plug them in, crank it out. One of your answers for n will be crazy. It'll be like negative or something, kind of a negative amount of terms. Just throw it away. Keep the other one. All right. All right, Drury Lane, 19 seats. So they have this 19 seats in the first row. So they have like a first row, 19. Second row, so every row goes up by 1 additional seat. So 20. Third row, 21. So right, it's kind of like a diamond pattern, you know, it gets wider and wider. Well, it's more like this. It's more like 19 seats in this row, then a few more in this row. It's only one more actually. Then a little more in this row, then a little more in this row, etc. It just gets wider and wider as it goes back, right? And there's 31 rows altogether. So how many total seats? Well, that's a fancy way to say add up the numbers. 19, 20, 21, etc. I don't know what the last one is. N equals 31 rows. Right? That's what they're asking me to do. So if you want to figure out how many seats in that theater, you need to add up the numbers, 19, 20, 21, etc., all the way up, 31 total rows. Right? So how do we do that? S sub n, we're adding them up. N over 2, A1 plus AN. What's n? Remember, n is always the number of terms. A1 is first term, AN is last term. So what's the number of terms? 31. 31 rows, 31 terms, right? There's 31 terms here. 31 rows. First term, 19. Last term, I don't know. Big question mark right there. What are you going to do? Put in the A sub n formula, right? Because it's A sub n. It's A sub n that's the last term. What's the A sub n formula? A sub n is A1 plus n minus 1d. So A sub n is A1. A1 is 19. Plus n minus 1. What's the d? D is just 1 every time. Right? The jump amount, the d, is 1. So that means A sub n is 19 plus n minus 1. A sub n is, what's that? 18 plus n. Take that, put it in right there. 18 plus n. Oh, and I know what n is, don't I? What's n? N is 31. Yeah, n is 31. Boom, 18 plus 31. There it is. Hit the buttons on your calculator. You get the number of seats. I like that one. Probably on the test. Ones like that. I think it's an important application of what we're doing. Make sure you know how to do that on that. All right, I'm going to move on with 5 minutes.